what we need to do whenever we have a circle that's not a unit circle. So yesterday, everything that we looked at was on the unit circle. So our radius was what? 1, right? The unit circle has a radius of 1. So today, we're going to talk about what happens whenever the radius is not 1. And the good news is that it's very similar to what happens whenever the radius is 1. So if I look at this picture, this is similar to what I was doing yesterday. I've got the circle, and I'm making a triangle here. Those coordinates right there are x, y, which means this right here is y. This would be your x distance. I was labeling it, and I'm going to label it right now on the bottom because that is the side of our triangle right there. Because if this is x, then that is also x right there. So that gives you this right triangle right here. But this time, our radius is not necessarily 1. They've called it just r, right? So this side right here is r. Yesterday, every time we did this, that was a 1. Now it's going to be an r. So if I want to find sine of theta for this, if I'm looking at that angle, sine of theta, and I'm looking at this triangle right here, what would sine of theta be? It'll be letters, it won't be numbers. It'll be y over, not x, r. Because sine is opposite over hypotenuse, right? And so if we look at that angle right there, y is the opposite side, and r is your hypotenuse. So if sine of theta equals y over r, would it be okay for me to multiply both sides by r? Cancel that r out like that. Okay, so that would mean that y would equal r sine theta. Now, yesterday, at the top of your unit circle paper, what did you write that r equals? Or, I'm sorry, what did you write that y equals? Sine, right? So y equals sine. Now, what if we use this formula instead? Is it still true? Y equals the radius times sine. For the unit circle, that radius is 1. So for the unit circle, it is the same thing, right? The only thing is yesterday, the radius was always 1, so we only had to put sine theta. But if our radius is something besides 1, then we can still find the y coordinate is going to be the radius times sine theta. So it's very similar to yesterday. We're just throwing the radius in there, which we could have done yesterday because the radius was 1, right? Cosine's very similar. Cosine of theta would be, if I look at this triangle right here, the adjacent side right here is x. The hypotenuse is r, so that's adjacent over hypotenuse. And if we took that, we got cosine of theta equals x over r. We could multiply both sides by r. And that means x is going to equal r cosine theta. So these are things you definitely need to have memorized. It should be something you almost had memorized anyway or were working on, because on the unit circle, y equals sine, x equals cosine. All we're doing here is multiplying it by the radius, right? That radius is different. Okay. Let's talk about tangent while we're here. Tangent for this, tangent of theta is going to equal, if you're doing tangent, that is opposite over adjacent. It is going to be y over x for that. Which y is r sine theta, and x is r cosine theta. So it's still true that tangent also just equals sine of theta over cosine of theta. The r's would cancel if you put them there, so that is still true. And I forgot yesterday to show you guys my sticker. I showed third period. Let me show you. I'm going to show you this on the document camera so you can see it. I got it the other day and I was so excited about it. Show it to you guys. Here. Check out my new sticker I got for my computer. You wouldn't have got it until now. But it's sine of gerene over cosine of gerene. What does that equal? Tangerine. So now you can get good math jokes like that because we know about this. All right, so I'm glad you enjoyed that. All right, so these two things are going to be the most important. Tangent, one other note I'm going to put about tangent right here. If tangent is y over x, so y over x, and the angle is in standard position, so it always goes through 0, 0, right? If I take y over x, that is like my change in y over my change in x, since I'm starting at 0, 0. So tangent of theta is always the slope of the terminal ray. So y over x is going to give you the slope of that line right there. So if you get a question about the slope of the terminal ray, tangent equals that slope for those. All right, so let's move on. So here's an example of something that you might be asked to do. We have this picture here, and we are supposed to find sine of theta, cosine of theta, and tangent of theta. Now, we just said that x equals r cosine theta, and y equals r sine theta. And we also, if we wanted, we could just use these two and we could figure it out. Or let's add in tangent of theta was y over x. There. Okay, so if we know those pieces, now there are other ways you could do this problem. It doesn't have to be this, but sometimes I can get myself confused doing these problems. So I'm going to do everything pretty much from these two formulas. X equals r cosine theta and y equals r sine theta, because I think those are the easiest to remember. So what is my radius of the circle? It is 5. And I know that because this point right here is at 5, 0. I also could do some Pythagorean theorem with my 3 and 4 if I wanted to, but it shows us that we've got 5, 0 right there. So that's, the radius is 5. So for this point, 3, 4, oh wait, actually I did this wrong when I did my notes. Actually, I did this originally, this is the angle that we were looking at. Is it the angle that we're looking at? It is not. Okay, I need to go back and fix my key over here, but good thing I caught myself before we did this whole problem. Angle theta actually ends all the way over here in this quadrant, right? So before we can answer these questions, we need to find the coordinates of P. What would the coordinates of P be? It will be 3, -4. because we know it have to have the same x coordinate right there, because you can see it crosses that x-axis there at that same point, same x coordinate. In order for it to be on a circle, the y coordinate has to be the same but a different sign for that. So that would be 3, -4 there. So this is actually the point we're looking at. I was using 3, 4 and did this wrong earlier. So if I want to know about sine of theta, I'm going to use y equals r sine theta. So the y coordinate is -4, the radius is 5, and I've got sine theta. And I want to find sine theta, so I just need to divide by 5. So sine of theta would be -4 over 5. That is one of my answers. Okay, we're going to do something similar for cosine. That is x equals r cosine theta. So x is 3 at that point. And then, are signs going to be right on this? Hold on. Yeah, they'll be right. Yes, they'll be right. Okay. And then 5 cosine theta. And here I have to divide by 5. And so I've got cosine of theta equals 3/5.
Where did you get the 3 from?
That it is our x coordinate of that point P. Yeah, so that point where your terminal ray crosses the circle, that's the point that you want to use for this x and this y right here.
So are we finding the angle of the little one and then going to subtract it? Or are we finding the big one right
The big one. Okay. Yeah. Although the angle of the little one would be the same. We're not, and this problem doesn't actually ask us to find the angle. It asks us to find sine of theta. So like we're stopping here, that's not our angle. Now, it would have to be calculator active because this is not a unit circle value. But if it were calculator active, you could do sine inverse and find the angle if it had asked you to. But they didn't really ask us to do that here. They just want us to find sine. And then tangent, the easiest way to do tangent is to remember that tangent of theta is y over x. So that is -4 over 3. That's your easiest way to do tangent. Tangent is just y over x. But let me show you another option if you forgot. The other thing that we know about tangent is that tangent equals sine over cosine, right? So I just found sine and then I found cosine. So another option for tangent of theta could be to do sine, which was -4 over 5, divided by cosine, 3 over 5. And so dividing fractions is easy as pie. Flip the second and multiply. 5's cancel. We get -4 over 3. It is easier just to use the y over x, but perhaps maybe you forget if it's y over x or x over y. Another way is just to do sine over cosine, because here, this right here was sine of theta divided by cosine of theta, because tangent is sine over cosine for that.
Since I'm weird, like what tells us to use point P? Like why aren't we using the point up there?
It is, and I missed this as well. They mark this angle right here as theta. So that circle right there in the middle.
Where it ends at?
Yeah, so you're going to pick where that ends at, because this is your initial ray right here, which should always be on the x-axis, and wherever it ends, that is what you're using for that. And I missed it whenever I did this too, because I wasn't really looking for the theta. I was like, oh, they put a point there. So I used +3 and +4 when I did this the first time. But they have marked that angle right there as theta, so you're looking at that. Okay. Questions? Okay, let's keep going. All right. Okay, for this one, we don't have any numbers other than the 0 that's given right here. They've drawn this rectangle inside of the circle. The first thing it asks us to do is find the coordinates of the points Q, R, and S in terms of X and Y. So Q, R, and S are these points here. For Q, we're looking for the points of this point right here. This point was X, Y. We'll have negative X, Y for that point. So Q is negative X, Y. It's in the second quadrant, so all your X's are negative over here, but the Y's are still positive. Okay. What would we get for R? Negative X, negative Y. Very good. And how about S over there in the fourth quadrant? X, negative Y. Okay, so B asks us to find the sine of the angle whose terminal ray intersects the circle at point S. So we're looking for the sine of the angle that intersects the circle at point S. So we're starting here, we're going all the way around to S right here. So there's our coordinates. And they're asking us for sine. Is sine X or Y? Is Y, right, on our unit circle. And so I know that Y equals R sine theta. Actually, okay, that's my formula. I'd kind of like it if they had not used X and Y's here. At point S, this is my formula, but at point S, what is my Y coordinate? It's negative Y, so that should be a negative right there. My formula is that Y equals R sine theta. I'm taking this negative Y and plugging it in for the Y because it is at this point. Does that make sense? If they had used like an A, B, it would make a little more sense, I think, there for me to be doing. Like if this was A, B, so this was A, negative B, we'd plug in a negative B right there for that. But they didn't do that. So if I want to know what sine of the angle is, then I would just divide by R. And so sine of theta would equal negative Y over R. And actually, I really shouldn't use a theta here. Why should I not use a theta? Theta's already marked, right? They already marked theta right here. So I really probably shouldn't use that letter over again because when I write theta, it should mean the theta that's right there. So I can just use like a different, let's use a different letter. Let's just use like a, they like to use Greek letters for angles. I'm going to use an alpha, which is like a weird, it pretty much is an A, but it's a little, it's hard to write. I don't like it that good, actually. But you could use like an A or B or C or something. Actually, don't use points, letters that are already in the problem, but you could use something else. But I'm going to be fancy and use the alpha there. Okay, so C says to find the tangent of the angle whose terminal ray intersects the circle at point R. So we're looking at point R this time. Let me do a different color so it stands out. So point R is here. That means this time our angle is going around to this point. Let's be fancy again. Let's call it beta. It's like it's a B, but the line is a little bit longer there for a capital beta anyway. So if I want to do tangent of beta, it is y over x. But at this point, my y coordinate is negative y, and my x coordinate is negative x, which actually just becomes what? Y over x, because a negative over a negative is positive. Okay, questions there? All right, let's keep going. Okay. These problems here are not that hard once you get the picture drawn for them, but they're wordy, they're long here. So a circle with its center at the origin of the xy plane has a radius of 3.5 units. So I'm going to draw that. I'll take it piece by piece. I've got a circle. Its origin is at the center, even though I drew it a little bit bad there. And its radius is 3.5, so this is 3.50 there. Okay. An angle alpha is in standard position with its terminal ray intersecting the circle at point 1.7, 3.1. What quadrant is 1.7, 3.1 in? It's in the first quadrant. So at least try to get your picture drawn so it's in the right quadrant at least. We got 1.7, 3.1, which is going to be, like, you're not going to go quite as far to the right as you go up, so maybe like about here. It doesn't have to be perfect. Oh, I thought I passed them out. Sorry. Okay, well, this, you have, I don't think we got it. I started passing them out. Do you guys have them? Okay, you guys don't have them. All right. The first, like, 3 slides were the same as the last ones I didn't get to yesterday, so you just get the number. Sorry about me all discombobulated there. Okay. All right. Okay, that better now? Okay. All right, so this point right here is 1.7, 3.1. And the angle alpha is in standard position, so that means this angle is here, and the terminal ray intersects at that point. So this angle right here is our angle alpha.
How did we figure out that this point goes there?
Since both coordinates are positive, we know it's in the first quadrant. I'm estimating,
Okay.
But since 1.7 is smaller than 3.1, I didn't go quite as far over as I went up. So that's my estimate of where it is at. It is definitely in the first quadrant. It definitely is somewhere over on this side of like your halfway point right there. So it's in this vicinity, but that's just an educated guess. So this one is asking me for sine of alpha. Which one is it, x or y, that I use for sine? Y. So our formula is y equals r sine theta, but let me go ahead and use alpha since that's my since that is my angle here. What is the radius? 3.5. What's the y? 3.1. It's just the y coordinate of that point. And then we got sine alpha. And it's asking us for sine alpha, which means we need to get rid of that 3.5. So we will divide. So you can either do that sine alpha equals 3.1 over 3.5 is 31 over 35 if you want to do a fraction. Or we could do a decimal for that. And I think it's going to be 0.886 if we round it off to 3 places. Just depend on which part of the test it's on, what they'll give you. Okay. Does that make sense? Okay, let's keep going. Okay. This picture here, the angle BAC, so we're looking at this angle right here, BAC, is shown on the graph to the left. Which of the following is correct? And all of these ask us about tangent. How do we find tangent of an angle? Y over x. So we'll be doing tangent of, it's BAC. I'll call it BAC. Is going to equal y, which is 7 over 6, divided by negative 0.8. Now, there are a couple of these I can rule out, or well, at least one I can rule out right now. Actually, there's a few I can rule out. Let's see if I can get it without even doing the problem. Tell me one I can rule out for sure.
B.
Why would you rule out B?
Because like 7 over 6 is both 1 and some negative.
Okay, good. That has got to be thrown out because this number is bigger than 1. This one is smaller than 1. So when we divide by a decimal, it actually makes it bigger. We should be getting something bigger than 1 here, and that is smaller than 1. So we can throw that out, which means also really C can go as well. There's another one you can throw out.
D.
Not D. A. Why can A be thrown out? Yeah, positive divided by negative gives you a negative, so A is out. So it has to be D, even if we didn't know how to do it. What is point, this would probably be a calculator inactive problem. What's 0.8 as a fraction? It's 8/10. So that's 7 over 6 divided by negative 8 over 10. Or you could do 4/5 if you want. And you got 7/6 times 10 over negative 8, which is going to give you 70 over negative 48. But those are both divisible by 2. So that'll be 35 over 24. And it'll be negative for that. And your tangent is your slope, right? So your tangent should be your slope. So we could have even ruled out B and C because the tangent and the slope weren't the same for that. So so there's lots of ways you could narrow that down. Even you could do this one without even doing the math on it, but that's how you do the math if you find yourself needing to. There. All right, just keep going. Okay, now this is going to go back to a little bit of unit circle stuff. An angle theta is in standard position in the xy plane. If tangent of theta equals negative 1, give all possible values of theta from 0 to 2 pi. Now, it did not tell us how big our circle was. Does it matter for tangent? It does not, because our formula for tangent of theta is y over x. It doesn't involve the radius, right? So for tangent, it doesn't matter what the radius is. We can still figure this out. How are we going to get a negative 1 when we do y over x? What type of numbers would we have to have?
One negative.
One of them's got to be negative, one of them's got to be positive. And they have to have the same magnitude, right? Like you can have a negative 3 over a positive 3. Or a negative 5 over a positive 5. But they have to have the same absolute value, right? So, because the radius doesn't matter, we can think of the unit circle. On the unit circle, where does this happen? On that unit circle, where do we have the values are the same except for one is positive, one is negative? Okay? It's going to be in the second quadrant. Over here, it's going to be the one that splits this in half, right? And it's going to be the fourth quadrant. Over here, it's going to be the one that splits this in half, right? So which one is this one? Yeah. What's the angle for this one in the second quadrant?
135.
It's 135 in degrees, but everything on this is. Those are the y values. It is asking us for the angle. So that would be, that's your coordinates over here. That's your negative root 2 over 2 and root 2 over 2. Go there. the angle is this inside part, it would be 3 pi over 4. What about the one in the fourth quadrant? What is the one in the fourth quadrant? It is 7 pi over 4 for that. So those would be our two answers. And even though we don't know the radius, we can figure it out. Okay, questions so far? All right, this one asks us for cosine A on number 6. Cosine is x equals r cosine. We're going to use an alpha since that's our angle here. What is our radius on the circle? It is 1. I find that just by looking at how far this goes over here. That's 1, right? And what is my x coordinate? Negative 0.8. So I got negative 0.8 equals 1 cosine alpha, which means that cosine alpha just equals negative 0.8 for that. Okay, we're okay here? All right, moving on. Okay, arc length. You do this in Math 3, so you might remember it. There is a more complicated and an easier formula for arc length. And I'm going to even show you the one for degrees just so we can relate it to each other. Because I use the more, actually, like in my mind, I have the more complicated formula stored there because it just makes so much sense to me. First of all, what is circumference of a circle? What's the formula for circumference? That is area. It's very similar. Everybody always gets those mixed up. It is 2 pi r. You can also use pi times the diameter, but we need to use the one with the r for this one. So 2 pi r or pi times diameter because the diameter is 2 radii, right? So like if we replace d with 2r, we would get 2 pi r. So circumference is 2 pi r. And arc length is the length of the edge of the circle. So basically it's just a fraction of the circle, right? It's a fraction of the circumference. So with degrees, which you're not going to be asked to do on the AP exam because it's all going to be in radians, but just so we can relate everything together. How many degrees are in the entire circle?
3. Wait,
Degrees. 360. Right? So I would take whichever angle I have, my central angle, and divide it by 360, and that's the fraction of the circle I've got, right? So if that's 50 degrees, I do 50 divided by 360, and that gives me the fraction of the circle I've got. And I would multiply it by circumference, 2 pi times the radius. Okay? That would be arc length in degrees. But for radians, I'm just changing one thing about that formula. What should I change about that formula I just had? Does the circumference change because I'm doing radians? It will not. The angle doesn't, the way I report the angle changes, but the value of it doesn't change. But if I'm doing radians, what's the whole circle? It's going to be 2 pi instead of 360, right? 2 pi equals 360 degrees. So this formula would be theta divided by 2 pi times 2 pi times the radius. That is arc length. And that's the one we are going to use. But, does anybody see anything that could happen here? Yeah, because that 2 pi r, it's not a fraction, but if I made it a fraction, it would have a 1 in the bottom, right? All that stuff's multiplied. This 2 pi can cancel with this 2 pi. So your easy arc length formula is theta times the radius. This only works if you're in radians. If you're in degrees, you have to use this formula, which you won't be in degrees on the stuff that's given to you in this class, but you might be somewhere else, right? So I wanted to point that out. So, so arc length is going to be pretty easy to find here. in most cases, once you get your picture drawn, that's half the battle on all of these. So, 7, the angle theta is in standard position on the xy plane. The circle P has its center at the origin and has a radius of 7. So let's draw this. We've got a circle. Its radius is 7. And it says the measure of the angle theta is 0.23 pi. Which quadrant is that going to be in? It's going to be in the first quadrant because this is pi, right? This is pi over 2, or we can think about it as half of pi or 0.5 pi, right? So 0.23 pi is going to be like somewhere around here. It's pretty close to 1/4 of a pi. It's pi over 4, but not quite. So my angle right here is theta. And it says, what is the length of the arc of the circle P? That's circle P, that's our center right there. Subtended by angle A. Subtended means like angle theta. Means our angle is right here. If an arc is subtended, it means that it is the arc between the 2 points where that angle intersects. So we're looking for this arc right here. So honestly, I still use the long formula for this. If I'm doing arc length, I think of it as a fraction of the circumference. So I do it this way. I do my angle, which is 0.23 pi, out of the whole circle, which is 2 pi, times the circumference, which is 2 pi times the radius. But as we just saw, the 2 pi's can cancel, right? Actually, let's plug in my radius. What is the radius? 7. There. So I am going to get just, and you could use the shorter formula, 0.23 pi times 7, and then I can, you may see this a couple ways. You might see them where they leave pi in the answer, so they just multiply 7 times 0.23, and it'd be like 1.61 pi. They might leave it like that, or they may type the whole thing in and get a decimal, 5.058 for that. So it just depends on whether they leave pi in the answer or not for that. Okay. Questions? All right, we're about out of time. Let me see. I'm going to do one more. I'm going to think about which one is the most important for me to do. Let's skip. Let's skip all the way to the end. Let's do number 12. I think you can still do the assignment, even though we didn't quite get through the examples. I know I was putting quite a few examples on here. But just do your best whenever we get to the assignment. Let's look at 12. Figure shows an equilateral triangle ABO with sides of length 8 in the XY plane. So the length of this side is 8. It's equilateral, so all the sides are the same. All the sides of that triangle are 8. What's the radius of the circle then? It would be 8 because the OB and OA go from the center to the outside of the circle. The terminal ray of an angle theta, which is not shown in standard position, passes through the point B. So if the terminal ray passes through B, we're talking about this angle right here, right? So the initial ray, if it's in standard position, always has to be on that x-axis, and we're going over to B right here, so we're talking about this angle. We want to know what is the value of 8 sine theta. To do this,